Imagine floating at the very edge of darkness. The event horizon stretches below you like a sheet of frozen black glass. In 10 seconds, you will cross the point of no return. 9, 8, 7. Okay, let's back up. How did we get here? A black hole forms when a truly massive star dies, collapsing into a point smaller than a single atom. All that incredible mass gets squeezed into a singularity. The gravity becomes so extreme that nothing can escape, not even light. That boundary, where escape becomes impossible, is called the event horizon. Think of it like a one-way door in space itself. Right now, you're approaching a stellar mass black hole, about 10 times heavier than our Sun. It's only about 20 miles across, but don't let the size fool you. From here, it looks like a perfect sphere of pure darkness, surrounded by a swirling, glowing halo of gas. That's the accretion disk, superheated matter spiraling inward at nearly the speed of light. Even 1,000 miles out, things are getting dicey. The accretion disk is blazing at millions of degrees, blasting X-rays and gamma rays in every direction. Without some serious protection, you'd be cooked in seconds. But let's say you have a magic spaceship that can handle the heat and radiation. What will the black hole itself do to you? At 500 miles, you notice something strange happening to the stars behind you. The light from distant galaxies is being bent around the black hole, like water swirling down a drain. Some stars even appear in two places at once, as the darkness ahead seems to swallow more and more of the sky. At 100 miles, you start to feel it. Your feet, pointing toward the black hole, feel heavier than your head. A lot heavier. This is tidal force, the difference in gravity's pull on different parts of your body. On Earth, this difference is microscopic. Here, it's just getting started. 50 miles out, time itself begins to break. This is where Einstein's bizarre predictions become terrifyingly real. To someone watching you from a safe distance, you would appear to slow down. Your movements become sluggish, then practically frozen. The light leaving your body has to fight harder and harder to escape the gravity, causing it to stretch out, shifting to red, then infrared, until you just fade away. To that distant observer, you never actually cross the horizon. You're just stuck there forever, a ghost frozen in time. But from your perspective, nothing special happens at the horizon. You don't feel a barrier. You don't hit a wall. You just keep falling. 10 miles, 5 miles, 1 mile. The tidal forces are now becoming immense, pulling you apart. Your feet are accelerating much faster than your hips, and your hips faster than your chest. This is spaghettification, the process of being stretched into long, thin strands like pasta. For a small black hole like this, these forces become fatal long before you even reach the horizon. Your bones snap, your cells rupture, your atoms begin to separate. Then you cross the event horizon. From your point of view, it takes less than a second, and that second is your last. The tidal forces are now so powerful, they are tearing individual atoms apart. You're no longer a person. You are a stream of fundamental particles, plummeting toward the center. And what happens at the singularity? Our known laws of physics simply break down. General relativity predicts a point of infinite density and infinite curvature. But most physicists believe that can't be the whole story. This is where quantum mechanics needs to step in, but we don't have a complete theory of quantum gravity yet. This is where science ends and speculation begins. Some theories suggest the singularity is a chaotic quantum foam. Others propose it could be a bridge to another universe entirely. We simply don't know. We can't know. No information can escape to tell us the tale. But wait, what if we tried this a different way? Let's rewind. This time, you're falling into a supermassive black hole. These are the giants that lurk at the center of galaxies, weighing millions or even billions of times more than our sun. Now here's the crazy part. Because these black holes are so huge, their event horizons can be billions of miles across. The gravity is spread out over a much larger area, which means the tidal forces at the horizon are surprisingly gentle. You could cross the event horizon of a supermassive black hole completely intact. You wouldn't feel a thing. You could have minutes, maybe even hours, of floating inside the point of no return before the tidal forces finally destroyed you. Imagine that. You're inside the event horizon, still alive, still thinking, watching the entire universe outside your viewport. But you're already a ghost to that universe. You can't send a signal out. You can't turn back. You are on a one-way trip to the center, and every passing second takes you closer to the inevitable end. Meanwhile, your friend watching from a spaceship far away sees the same thing as before. You slow down, redshift, and freeze on the horizon, an eternal, fading image. This is the mind-bending reality of relativity. From your frame of reference, you fell in and were gone in hours. From their frame, you're still there, stretched and frozen for all eternity. Both views are completely correct. Black holes are where the universe shows us the absolute limits of reality. They're places where our familiar rules stop working, where time becomes flexible and space tears itself apart. We've detected the gravitational waves from their collisions and even photographed the shadow of one in a distant galaxy. But we will never, ever see inside one. The event horizon is a one-way door in the very fabric of existence. Falling into a black hole means you would witness the most extreme physics in the cosmos, see time itself break, and feel space pull you apart. Before vanishing from the universe, you knew into a realm beyond our comprehension. The darkness at the edge of space isn't empty. It's full of questions we're only just beginning to ask. Thanks for taking this journey with me today. If you enjoyed diving into the edge of reality, hit that subscribe button. I'll see you in the next one.